Hello, my name is Pavel Shturko, and today we're going to write a little program to see if we can fix a sales glitch by playing with stocks. So the basic background behind this problem is that we receive, we are giving an array of stock prices. These stock prices occur at a particular time, so our index symbolizes the time at which that price of this stock occurred. So for example, index 0 symbolizes 7 a.m., index 1 symbolizes a.m., so on and so forth. So the goal here will be to find, the maximum profit where the minimum value or the minimum price occurs before the maximum price, hence yielding to us the maximum profit. Hence, let's talk about the possible solutions for this. First one, the most obvious one, you check all possible pairs. So you take all and choose two pairs. This will run for us in big O of n squared time, which is not the most optimal solution. So we can do a little bit better than that. We can definitely do this in n time. And so here's the basic approach behind this. We keep track, we store a minimum and essentially calculate the profit by tracking the difference between this minimum and any values that occur after it. This is sort of a dynamic programming approach because we have encountered a potential minimum in the past, and we have the maximum profit that we've encountered so far. So we calculate based on the values that come after it. If you want to learn a little bit more about it, feel free to Google this sort of problem, and you'll get a thorough, detailed explanation of the right reasoning behind this, the exact reasoning. Okay, so let's write a little function for this approach that I've just explained. Public static. We're going to return the maximum profit, and so this name is getMaxProfit. Okay, and so one little edge case right off the bat that I see is we can identify the length of the array and do things about it right away. So if we get something less than length 2, we get 1 element, we get 0 elements. There's no profit. There's nothing we can work with at that point. So there's no profit that can be calculated, so we can just return a 0 profit. Okay, and as I mentioned, we're going to store a minimum, so we can start with the first, we can presume that sort of the first element will be our minimum, and we also want to store the profit, which initially will be 0. So we're going to go through this array, and we're going to start at the next element, as in we already assigned the first one to the minimum, so we're going to be using it. So there's no really need to go through it again. Length. Okay. So as I mentioned, if we counter an element that is lower than our minimum, then we want to replace it because we've encountered a new minimum that is potentially better and might potentially lead us to a better profit. Okay, so now our potential profit will be the difference between the current element and our minimum, because this if statement above that calculates the minimum, it won't change with every single value. It will only change every now and then. So it's okay if we use the same minimum that we encountered to potentially the potential profit. That way, the current value that is also our current minimum. That's going to give us a potential profit of 0, but that's not going to get overwritten to our profit variable due to it being smaller or equal, depending on what the case is. So we're not too worried about it, but I did skip that first element because I used the first element as the minimum. So explicitly what I'm talking about is this check right here. We only replace this profit if it's less than our, we'll only replace our profit outside the loop if our potential profit encountered so far is not smaller but greater. Okay, and so we assign it, and at this point we return the profit, and this should yield to us the maximum profit that can be calculated from this array. So by inspection, by looking at this, we can see that the maximum one will be 40 and 200. It will give us a maximum profit of 160, although the global minimum is 20 and the global maximum is 200. That doesn't work that way. 200 maybe minus 150, that's 130. Still not what we were looking for. So 40 and 200 definitely looks like our best solution, our maximum profit. So let's see if our little algorithm agrees with that. Profit. Okay, and let's run this, and as you can see, our maximum profit indeed is 160. This can be easily modified, to sort of add the indices that we were using, but I'll leave that to you as a potential exercise if you want to play around with this problem a little bit more. And as I mentioned, there are plenty of resources regarding this problem online, so feel free to browse any of them. But here's a guided solution that I present to you. So thank you very much for listening, and till next time.